Hey there, Internet, it's Nick. Welcome to Generalized Abstract Nonsense. And don't forget to go follow me on Twitter, and if you haven't already, like and subscribe both here and at the Cult of Pure Reason channel. Today we're going to talk about propositional logic and those who pretend to know it. Unfortunately, there are people who pretend to be experts that are teaching people absolute nonsense that they're presenting as logic. Today's example is Jewell. He's a magician, a self-proclaimed scientist, philosopher, and expert in propositional logic. He recently released 3 videos called Intellectual Kung Fu. They ostensibly teach propositional logic. Well, let's see how he did. There will be links to his videos in the cards and in the description. There will be timestamps for quotes. The first video is about burden of proof and proving a negative. It's a rule in propositional logic, and it's called burden of proof. I'm going to show you some stuff about propositional logic, and then let you decide whether or not this is a reasonable claim. Propositional logic is calculus of propositions. It's about how whole ideas are connected. It deals with how to get from some ideas to others. Propositional logic has 2 kinds of rules. Rules of inference and rules of replacement. I'll give you an example of each. This is a simplified version of the Kalam cosmological argument, where I just did a universal instantiation to make it valid in propositional logic. It's an example of one of the most common inference rules, called modus ponens. It takes just 2 propositions and infers a third. The first is an if-then statement that we call a conditional. The second is just a basic idea called an atomic proposition. Atomic proposition is the same as the first half of the conditional, called the antecedent. If you have a whole conditional and the antecedent of the conditional, modus ponens lets us infer the second half of the conditional, called the consequent. Logic doesn't care what the content is, just the structure. So anytime you have this situation, modus ponens applies. We'll see modus ponens a few more times before the end of the video. This is double negation. It is one of the most common replacement rules. Replacement rules let us take an idea and swap it out for another in its place. We have one, no matter what it is, we can swap it in for the other. Double negation lets us replace an idea with not that idea, and vice versa. Now that we have an idea of what kinds of things are rules in propositional logic, let's see what this burden of proof rule is. The burden of proof simply states that whoever is making a claim has the responsibility of demonstrating the truth of that claim. This should clearly be a different kind of thing. It bears no resemblance to our inference rules and our replacement rules. So it shouldn't shock you that burden of proof is not a rule in propositional logic. In fact, burden of proof has nothing to do with propositional logic. It's a part of rhetoric and debate. That's an adversarial subject where this sort of restriction on interlocutors makes sense. Propositional logic, however, is not adversarial. There isn't even an interlocutor. So it's not the kind of discipline where a thing like burden of proof is meaningful. The short answer is you can't prove a negative. You can't demonstrate the non-existence of something. Simply put, you can't prove a claim to be false. Well, this is a complete myth that spreads like wildfire online with the new atheists who don't know logic. I don't know why, it just does. It's fashionable for some reason. There are tons of ways in which one can prove falsity in propositional logic. In fact, in propositional logic, among many ways to prove a negative, there's a dedicated rule called proof of negation. It's a simple 3-step process. First, assume the thing that you want to prove false. Second, derive a contradiction. Third, infer the negative of the thing you just assumed. In addition to this, Jason will continue on in his video and give us another method of proving negative. Because it seems you really can prove a claim to be false. Well, that's because you totally can. And in fact, in just 2 minutes and 17 seconds in his video, he's going to give us one of the many ways to just do that. If you prove your assertion to be true, by consequence, you've demonstrated theirs to be false. This is literally a method for proving something to be false. The word demonstrated in logic is a synonym with proved. Consequence is another logic keyword. If something is a consequence of something else, then it is also the consequent of a conditional where the other thing is the antecedent. So we have a situation where we have both a conditional and that conditional's antecedent. So here comes modus ponens again, give us the falsity of something this time. If your claim is true, then their claim is false. Your claim is true, therefore, by modus ponens, their claim is false. He literally just used the inference rules of propositional logic to prove a negative, which, ironically, proves his assertion that you can't prove a negative to be false. There's no logical content in episode 2. It's just him doing a circle jerk with the new atheists over the entirely pointless debate over the definition of atheism. Since definitions are neither true or false, you just need to let people know what definition you're using and make sure to use that definition consistently. Take 10 very awkwardly timed seconds to try to determine whether or not the argument is valid. It would have been easier if he had told us how to determine whether or not an argument is valid. He gave no such instruction and won't at any point in the video. So I'll tell you what validity is and a simple way to check for it, and then we'll show that he's actually wrong about his example. An argument is valid if and only if the premises cannot all be true and the conclusion false. Keep that in the back of your mind while we go back to the conditional for a moment. A material conditional is false only when the antecedent is true while the consequent is false. The astute viewer might also have noticed that these sound very familiar, and the astute viewer would be correct. We can use this similarity in a test for validity by turning the argument into a conditional. We just take all of the premises and connect them with and make that the antecedent of a conditional where the conclusion is the consequent. If there are no ways that this conditional can be false, then the argument's valid. If there are ways for this conditional to be false, then the argument is not valid. So, let's take a look at his argument. 1. All men always tell the truth. 2. Donald Trump is a man. 3. Donald Trump always tells the truth. We'll simplify this by breaking it down into the smallest chunks of whole ideas, and then make those letters. The form is P, Q, therefore R. Well, there's no conditional in the argument, so we know at least it's not modus ponens. And I haven't told you any other inference rules, so let's make this argument into a conditional and check its truth table to see if it can be false. So, are there any ways that if P and Q, then R can be false? Yes, so it's invalid. In fact, this argument has the same form as the prototypical example of an argument that is invalid in propositional logic. It's the same structure as 1. All men are mortal. 2. Socrates is a man. 3. Socrates is immortal. The Socrates version and its invalidity is used as motivation for learning the first order predicate logic. In predicate logic, we break down the individual ideas, so we turn our letters into a combination of uppercase and lowercase letter. This represents something, the lowercase letter, having a particular property, the uppercase letter. In predicate logic, the form becomes for all x, if x is a man, then x tells the truth. Donald Trump is a man, therefore Donald Trump always tells the truth. And this is valid. If we show the implied universal instantiation of the first premise, then we see that we have a conditional and its antecedent, so we can infer the consequent. Yes, it's modus ponens yet again. The logical absolutes are 3 specific laws that are the foundation of all rational thought. They are the foundation of all valid mathematics, all rational discourse, really, the foundation of reality itself. The logical absolutes are true everywhere, all the time. They're true throughout the entire universe. They're true in whatever universe could possibly exist. So these quotes are a huge red flag. If you hear somebody talking about logical absolutes and making these claims about them, you know right away that they don't know what they're talking about. This isn't from logic, it's from presuppositional Christian apologetics. It's been spread to new atheism by way of Matt Dillahunty uncritically accepting these claims from Matt Slick. There are 5 claims here, and all of them are wrong. 1, that they're the foundation of all rational thought. 2, that they're the foundation of all valid mathematics. 3, that they're the foundation of reality itself. 4, that they're true everywhere. And 5, that they're true in whatever universe could possibly exist. When we say that logical absolutes don't exist, we're saying that there are no things with these properties, not that the things that they mistakenly call logical absolutes are never true. It's like in philosophy of biology, when they say that genes don't exist. They're not denying the existence of DNA or coding segments that get transcribed into proteins. They are denying that there's anything having the properties that Mendel used to define genes. So what are they? The law of identity, the law of excluded middle, and the law of non-contradiction. These are just a few of the axioms of an extension of first-order predicate logic that includes identity. And even if we ignore the law of identity and treat the other 2 as axioms for propositional logic, that is only part of one axiomatization of propositional logic. There are other equivalent axiomatizations of propositional logic. A common one, in fact, is the one that we used in my graduate course where we did things like prove the consistency and completeness of propositional logic. It's called CL, which stands for classical logic. It has 12 axioms, none of which are the law of identity or the law of non-contradiction, though the law of excluded middle is one of them. Interestingly enough, its only rule of inference is modus ponens. So let's start with number 1, the law of identity. Number 1, the law of identity. Something is what it is and is not what it is not. Everything is identical to itself. A equals A. The law of identity is not true in propositional logic. In fact, it's not even expressible in propositional logic. Propositional logic does not have the concept of identity. There are 5 operators in propositional logic: negation, conjunction, that's and, disjunction, that's or, conditional, that's if then, and biconditional, that's if and only if. The closest thing to identity in propositional logic is the biconditional, but that just means that 2 ideas are true under precisely the same conditions. If the law of identity is the foundation of all rational thought, and it's not true in propositional logic, then it seems that propositional logic doesn't count as rational thought. Number 2, the law of excluded middle. For every proposition, either that proposition is true, or its negation is true. The statement, "you are pregnant," that is either true or false. This is conflating 2 concepts, bivalence and the actual law of excluded middle. Bivalence is just a fancy word for there being precisely 2 truth values. The law of excluded middle says that either a proposition or its negation is true. These often go together, but they are not the same thing. If the law of excluded middle holds, then double negation works. If it doesn't hold, then double negation does not work. Using that fact, we can show a concrete example of a situation where the required logic is bivalent, but the law of excluded middle does not hold. All you have to do is allow sets to grow. If you can have stuff that's in the set now, stuff that isn't in there now but will be in the future, and stuff that will never be in the set, then double negation doesn't work anymore. Since the double negation doesn't work, we note that the law of excluded middle doesn't hold. If you're interested in more rigorous treatment of this example, check out the link in the description to a talk on intuitionistic type theory aimed at programmers. Here's valid mathematics where the law of excluded middle doesn't hold. In fact, most of the things that have logic don't have the law of excluded middle. As a general rule, topoi, things that have logic, do not have the law of excluded middle. So it shouldn't be surprised to learn that the law of excluded middle doesn't hold in the topos formed by quantum mechanics. There is a link to a good paper on that in the description. Number 3, law of non-contradiction. Something cannot be both true and false at the same time in the same sense. There are in fact logical systems where there can be non-explosive contradictions. A logical system where there can be non-explosive contradictions is called paraconsistent. A good example of a paraconsistent logical system is first-degree entailment. A really cool thing about first-degree entailment is that it has more than 2 truth values. It isn't bivalent, but it is paraconsistent. If you're interested in logics where the law of excluded middle doesn't hold, where there are finite but more than 2 truth values, where there are infinitely many truth values, or where the law of non-contradiction doesn't hold, I strongly suggest the book Introduction to Non-Classical Logic by Graham Priest. It's a zoo of sorts of these kind of logics. While I'm recommending books, a good book on the subject of what logic is, where it comes from, and how to tell what kind of logic is appropriate for what situation is Goldblatt's text Topoi, The Categorical Analysis of Logic. Though it might be rough if you have had absolutely no exposure to category theory before. In that case, I'd also recommend Lawver's text, Conceptual Mathematics, as it is the single best very first exposure to category theory that I've ever seen. I'll put the links to these books in the description. I'm afraid there really is no way around the logical absolutes. I mean, if you were to show these laws to be flawed, you would change the academic structure of logic overnight. Yeah, this is just a hand-waving appeal to authority, and it's an authority that doesn't exist. Academia doesn't believe in logical absolutes, and for good reason. There are different logics for different jobs. And just as we've seen, the supposed logical absolutes don't hold in all of them. I didn't come up with these examples, nor did I come up with topos theory. These are established logic in math. None of this is obscure, and any academic in the relevant fields would know about them. there would be no change in academic structure because this is already where the academic structure is. You don't have to take it from me either. Nothing I said so far or will say in the rest of the video is controversial or hard to find. You can hop on Wikipedia or the Stanford Encyclopedia of Philosophy and look up intuitionistic logic and pair-consistent logic. Jason is doing nothing but bluffing here. Call his bluff and check it out for yourself. The rest of Jason's video is spent listing off what he thinks are logical fallacies that show that your argument is invalid and or has false premises, but rather than listing off actual logical fallacies like affirming the consequent that show that the structure of your argument is invalid, he listed off informal fallacies that have nothing to do with propositional logic. Informal fallacies don't show invalidity and often don't even show unsoundness. For example, we'll take his example of circular reasoning. Circular reasoning happens to be valid. In case you don't believe me, we'll do our truth table test. Look, there's no way the conditional can be false, so it's valid. And if the idea in our circular argument is true, then our circular argument is not only valid, but also sound. Again, he's bringing up things in rhetoric and debate that aren't things in logic. It should be clear that Jason is not a good source if you actually want to learn about propositional logic. If you are interested in learning logic, like, comment, and subscribe, and if there's enough interaction, I'll put together some actual logic lessons. We can do propositional logic, first order quantified, we can do modal, whatever you want. If we go long enough, we can do cool stuff like first degree entailment and topos theory. And if you want to see the kind of nonsense that Jason says about logic on Facebook, check out this playlist by Pete Finch to the left. And if you want to watch me and Gaspar roast bad arguments, check out our roast of inspiring philosophy to the right.